Assalamu alaikum. Today we will learn to write a balanced chemical equation, Ionic equation including state symbols. First of all, what is chemical equation? Chemical equation is the representation of a chemical reaction by the symbols and formula. And to write the chemical equation, we should know number 1, symbols of element, and number 2, formula of compounds that are participating in chemical reaction. So we have to learn and remember the name of the compounds and other formula to write the chemical equation. Some examples of the symbols and the formula are symbol of oxygen O2, not O. Similarly, symbol of hydrogen, that is H2, not H. Same for the nitrogen, that is N2, not H. These are like that? Because these elements are not present in their free state at atomic form, so they are always present in a molecular state. So that's why their symbol will be written as O2, H2, and H2, etc. And other some compounds, for example, sodium hydroxide, that is NaOH, nitric oxide, your nitric acid, that is HNO3, sodium chloride, like NaCl. So these are the some examples to write a chemical equation. So you have to learn or remember the chemical formula and the symbols of the element. You can predict the chemical formula from the periodic table. As in a periodic table, the same group element usually have the same formula. If you know the formula of the one member of a group, you can write the formula of other members too. For example, if you know the formula of sodium hydroxide, if you know the formula of sodium hydroxide or the sodium sulfate, whatever, that is the Na2SO4, you can write the same formula for the potassium sulfate, because the sodium and potassium belongs to the same group, so respectively their formula will be the same, that is K2SO4. So in this way, the same group element usually have the same type of the formula. So this is a hint or a trick to remember the formulas for the some compound. If you know the chemical compound or formula for the one element or one group member, you can write the formula for the other group members too. Is it clear? So the next step is how to write a chemical equation. From the description, then how we can write the chemical equation. How to write equation. So what to do? Just to read a statement. We just need to read a statement and do the following step. Which steps are involved? Number 1, converts the words into their formulas. Number 2, decide the reactant and product. And number 3, write the reactant on left side and product on right side. And number 4, an arrow which runs from left to right. So by following these 4 steps, you can write a chemical equation from any description. Is it clear? For example, we have a description like that. The calcium hydroxide. This is a description. Then carbon dioxide and calcium hydroxide are combined to form calcium carbonate and water. So let's pause. This is a description. So by following this step, we can write the chemical equation for that description. Number first is words into formula. जो भी whatever the words we have, we convert these words into their formula. Like that, carbon dioxide. The formula for the carbon dioxide is CO2. Similarly, calcium hydroxide, that is CaOH twice. Similarly, for the calcium carbonate, CaCO3, and water, H2O. So we convert the words into their formula. Second step, decide what is reactant and product. From the description, it is clear that the whatever the things or the substance which are combining, they are acts as a reactant, and the new things which are produced, they are called as product. So from the statement, it is clear that carbon dioxide and calcium hydroxide are reactant, and calcium carbonate and water, they are product. So according to step 3 and 4, we write a reactant and product, and then we write an arrow. So final, we have the chemical equation like that carbon dioxide plus calcium hydroxide gives us, that is an arrow, calcium carbonate and water. So this is a chemical equation from the description by following these all 4 steps. The next step is to balance this chemical equation. Now, how we can balance? You just count the number of atoms on both sides, that is on the reactant and product side. And we have the same number of atoms of the respective elements on the reactant and product side. For example, the C for the carbon is 1 here, and carbon 1 here in the product side. Same for the calcium, 1 Ca from the reactant and 1 calcium at the product side. Okay, now if we talk about oxygen, 2 oxygen of from here, and 2 oxygen of here. That is 4 oxygen on the reactant side, and 3 oxygen and 1 oxygen, 4 oxygen on the product side. So oxygen is also balanced, and hydrogen, 2 hydrogen from the reactant and 2 hydrogen from the product. So this is a balanced chemical equation. Is it clear? Okay, if we take another example, let's take another example. Example is that the hydrogen peroxide decomposed to form water, decomposed that to break down. Hydrogen peroxide decompose to form water and oxygen. So this is our description. So how we can write the formula? Again, we follow the steps. Number 1, write the formula of the product, of the substance. Hydrogen peroxide, that is H2O2. Water is H2O. Oxygen is O2. So applying the rule. The substance which is decomposed, they are reactant, and the new things which are formed, they are product. So H2O2 gives us H2 and H2O and O2, oxygen. So here is hydrogen is balanced. 2 hydrogen on the reactant side, 2 hydrogen is on the product side. But oxygen is unbalanced. 2 oxygen is here, 2 and plus 1, 3 oxygen on the product side. So to balance oxygen, we write a suitable coefficient until we get it in the right form. So this is done by practicing and trial and error method to find out the right coefficient for the equation. So if I balance this equation, so H2 and O2, I apply 2 here, and again here is 2 to the 4 hydrogen will be here. So to balance the hydrogen, we apply 2 here again. So 2 to the 4 hydrogen. Now oxygen will be 2 to 4 oxygen on the reactant side, and 2 and 2 1 is 2 plus 2 4 oxygen on the product side. So this is a balanced chemical equation. Is it clear? So most of the reactions are balanced by the whole number coefficient like 2, 3, 4 and 5. But some reactions can be balanced by using the fraction and decimal. For example, if you take an example or from the burning of the benzene. Benzene is a organic compound. So if you take the burning of example of burning of benzene, that is benzene formula is C6H6. When it combined with oxygen, it formed the carbon dioxide and water. So if you see the equation, 6 carbon here, 1 carbon here, 6 hydrogen here, 2 hydrogen here, 2 oxygen here, and 2 oxygen, 2 plus 1, 3 oxygen here. None of any element is balanced. So we will balance it by applying or by some multiplying whole numbers. So if 6 oxygen is here, so to convert the carbon 1 into 6, we multiply it with the whole number 6. Is it clear? And again, here the 6 hydrogen, here the 2 hydrogen, so 3 to the 6, so 6 hydrogen will be here. Now what about the oxygen? Oxygen will be 6 to the 12 oxygen will be here, and 3 oxygen will be here, so total will be the 15 oxygen, and here is the 2. So there is no any number by multiply 2 I will get the 15. So if I applying a fraction, that is the 7 1 by 2. So by simplifying this fraction, we again get the 15, that is 7 to the 14, 14 plus 1, 15 by 2. So 15 by 2 multiplied by this 2, answer will be the 15. So by using some fraction, we can balance a chemical equation. Is it clear? So in a chemical equation, we also write some state symbol for the better understanding and for the explanation. For example, for solid, we write the state symbol small s. For liquid, we write the small state symbol like small l. For gas, we write the small g. And AQ for aqueous solution. Aqueous solution, that is the solution, anything which is dissolved in a water, they make the aqueous solution. So we write the state symbol AQ. So it is essential to write the state symbol in some cases, but in most of the reactions we omitted it. For example, we write the state symbol in those reactions in which we have to write the energy change, and while in our organic reactions we don't need to write the state symbols. Is it clear? So for example, an equation is that the silver nitrate, solution of the silver nitrate and the calcium chloride. Solution means that dissolve in a water, so they will form a aqueous solution. So silver nitrate, that is AgNO3, and the calcium chloride, that is CaCl2, as they are solution making substance, so they will be aqueous. Is it clear? They are combined together to form a precipitate of the silver chloride. Silver chloride AgCl. Precipitate mean they are present in a solid state. Precipitate, those substances that settle down after the chemical reaction. So they are in solid state. So we will write S here. And the solution of the calcium nitrate. So it is a solution. So I will write the aqueous here. Is it clear? So by the description we can understand what is the state symbol of a given substance. Is it clear? So conventionally the chemical reactions has a single arrow, just like that, this, which runs from reactant to product. But some reactions are reversible. Reversible means these reactions can run from left to right and right to left on the both sides. Is it clear? And they are represented by a double arrow, by representing the two arrow. So some reaction conditions are indicate on the arrow. We can, all the reaction conditions, whatever they are present in a given reaction, they are written on the arrow. For example, if we have a reaction like that, C2H4, C2H2 plus H2 gives us C2H6. This is the hydrogenation process. So in this reaction we need some reaction condition. So we have to add some catalyst here, and temperature should be 250 to 300 degrees Celsius here. So whatever the reaction condition that are necessary, we write on the arrow, and arrow will be drawn on in a longer form. Is it clear? So this is all about the chemical reaction. The next topic is the ionic equation. Now, what is the ionic equations? Ionic equation shows any atoms and molecule that are involved in a chemical reaction, but only the ions that are react together, not the spectators ion. Spectators ion that are ions which do not participate in a chemical reaction. Is it clear? So by simplifying the equation, we can write only those ions which are responsible for the chemical reaction, and other ions are omitted. So for the ionic equation, only those compounds which are water soluble, they form the ions, and other will be remain in the solution. To simplify this given equation, we have to do the following step. Number 1, to simplify or to solve the equation. Number 1, write the full molecular balanced equation. Just to write the full molecular balanced equation. Number 2, split compounds into their ions. Is it clear? Number 3, or the next step is delete the spectator's ion. And the last step, that is write the net equation. Is it clear how it will be done? For example, when the solution of the sodium chloride and the silver nitrate react together, they form the precipitate of the silver chloride. Solution of the sodium chloride, if I write the chemical equation of this description, the solution of sodium chloride formula is NaCl, and as it is in a solution formation, so I will write the symbol state Aq. And silver nitrate, AgNO3, again it make the solution, so I will write aqueous here. They will react together to form the precipitate of silver chloride, and they form the precipitate that is solid form, so I will write is here. And solution of sodium nitrate, sodium nitrate, at it is present in a solution, so I will write the aqueous here. Is it clear? So the first step is that to write the balanced chemical equation, I have write the balanced chemical equation here. Is it? So second step, to split the compound in their ions. Sodium chloride will split into the Na plus Cl minus, and they are in aqueous solution, so I will write the aqueous here. Is it clear? Same from the silver nitrate, aqueous solution, nitrate, NO3, aqueous solution. They gives us, as they are present in a solid state, so they doesn't dissolve in a water, so they remain AgCl. And again, it is an aqueous solution, it can be break into their ions, that is sodium and nitrate in aqueous solution. Is it clear? The third step is to delete the spectator's ion. Spectator's ion, the same ion on the both side. So sodium is here, nitrate is here. These ions will cancel out with each other. Is it clear? So the remaining ions which are present here, they are chloride ion, Cl, aqueous, plus silver ion, Ag aqueous, gives us AgCl. This is our net equation. It means only these ions which are present in a solution, silver and chloride ion, they are responsible in a chemical reaction, while the other ions are spectators ion. They are not involved in a chemical reaction. Is it clear? So to understand it, take another example. Let's suppose the carbon dioxide gas pass in a aqueous solution of the calcium hydroxide. Calcium hydroxide aqueous solution, and carbon dioxide gas pass through it. It will give us calcium carbonate, precipitate of the calcium carbonate. Precipitate mean they will settle down and water will be the form. Water is in a liquid state. So the first step is to split these ions. If we split the ions, the calcium ion and OH ion, so they are present in a aqueous solution, so I will write the aqueous here. And the carbon dioxide is in a gas form, so it will not decompose into the solution, it will remain as gas. The next is calcium carbonate is in a solid state, so again it will not decompose in the solution, and water is in a liquid state, again it will not decompose. So here in this equation there is no spectator's ion, this is our ionic equation. Is it clear? And take another example. For example, the aqueous solution of ammonium sulfate. Ammonium sulfate formula is NH4 2SO4. As ammonium sulfate and sodium hydroxide. Aqueous solution of ammonium sulfate and sodium hydroxide. So they are present in an aqueous state. Sodium hydroxide. They gives us that sodium sulfate, Na2SO4, and again it is present in an aqueous solution, water, and the last one is ammonia gas, NH3. So to balance this chemical equation, I will write a 2 here and a 2 here. So this is a balanced equation. So you have to do just to convert this balanced equation into the ionic equation. So following the step number 1, to split all the aqueous solution compound into their ions. So ammonium NH4 present in aqueous solution, sulfate ion aqueous solution, again sodium ion aqueous solution, and OH ion again be present in aqueous solution. And if we move to the product side, so this is an aqueous solution, so 2 sodium ion, sulfate ion, SO4 minus 2, this is again aqueous solution. Water is in a liquid state, so it will not decompose. Ammonia is a gas, so again it will not decompose, it will remain the gas. So subtracting the spectator ions, so sodium and sulfate and sodium. So what will be the next equation? 2 ammonium ion, that is aqueous, and 2 OH, that is aqueous. They give us H2O liquid and ammonia gas. So it means ammonium ions and OH ion which are present in a solution, they are responsible for the chemical reaction. So this is the whole about the ionic equations. Thank you.